Topics in Math 1.1 Part 2. Union and intersections of sets, inequalities, interval notation, and graphing. Lots of review this section. Some new stuff. Alright, evaluate b squared minus 4ac if a is 2, b is negative 3, and c is 3/4. Number 2, let a be negative 1/3, b be 4/3, and c be 2. Go ahead and pause the video and see if you can come up with these. Alright, if we finish up that first one, we should have gotten number 1 is 3. So don't forget when you multiply a number times a fraction, multiply the tops and then multiply the denominators. The numerators first, then the denominators. If there was no denominator, like on this 8, put it over 1. Okay? So then you can multiply straight across and get 24 over 4, or you could corner reduce and get 6 right away. And then 9 minus 6 is 3. Okay, the second one, plug everything in. Don't forget when you square a fraction, you need to multiply it by itself. So 4/3 times 4/3. So it'd be 16 over 9. Okay, then we've got a negative times a negative, which will turn to positive 4/3. And then times 2. So then we can multiply straight across again, and we get 8/3. Now we need a common denominator, which would be 9. So our answer should be 35/9. All right, some definitions. So a set is a collection of objects. A lot of times you'll see a set written in math. Like this, and then with a list of numbers. There are some varieties of how to write that. Elements are going to be the objects that are in the set. So if we had 2, 3, and 4, our elements would be 2, 3, and 4. Integers, you can use this Z letter to stand for integers. And then this kind of funky E stands for element. So that would just be like, what are your elements? 2 is the element of the set. Sets can be described using braces. So we can say A equals X, and then this line means such that X is an integer between 0 and 7. What does that mean? So since there was no or equal to, that means it can't be 0. It's got to be more than 0. So the first integer listed would be 1. Again, it can't be 7. The last integer listed would be 6. And then all the numbers in between. So if it says set A can be described as X is an integer between 0 and 7, then set A would actually be the numbers 1, 2, 3, 4, 5, and 6. All right, union. If we had a set called S, and then this kind of looks like a U, stands for union. This means that we want all of the elements in S and all the elements in T. So we call this an OR because S or T has to be true, but not both. Okay? This one is kind of like an upside down U. This means the intersection of S and T. Okay? And only the elements that are in both sets will be the intersection. We'll practice this here in a minute. Okay, empty set is just that 0 with a line through it. That means it has no elements. All right, example 1 here. So we're given the sets S, T, and V. Find S and T. Okay, so this one, both need to be true. So both needs to be in both. We'll say both needed. So what element is in both S and T? So 1 is in both, 3 is in both, 5 is in both, and 7 is in both. So we're going to say 1, 3, 5, and 7. Okay, so the intersection of S and T would be 1, 3, 5, and 7. This one is the OR. So this one's kind of like the AND, the intersection This one's the or, so we call it the union. So think about like the union of a marriage. You're joining both families together. You don't need to pick one side or the other. We're all together. And then the intersection would be the two people that got married now are in both families. So that would be kind of like the intersection. Okay? So the union would include everything. So everything from the first and everything from the second. So 1, 2, 3, 4, 5, 6, 7, and then 9. Okay, you don't need to repeat it. Any of them that were repeated, just list them all out. All right, this one, T or V and S. Okay, so T or V would include all the numbers that are in T and V. So it can be any number from T or V. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now we need to include the and S part. So we want to say which of these numbers were in T or V and are also in S. So if you kind of go back and look through which ones are in both, 1 was in both, 2 is in both, 3, 4, 5, 6, 7. Those are all in both, but the 8, 9, 10 are not in both. They're only in the one, so we're not going to include those. Okay? So T or V and S would be 1, 2, 3, 4, 5, 6, and 7. All right, interval notation. So interval notation, open interval has parentheses. That means that it can be greater than this number, but less than this number. So for example, if I wanted something that was greater than 3, but less than 7, I'm going to put 3 and 7 on my number line with open circles there. Okay, and then in the interval notation, we would write that it is between 3 and 7. Okay, closed interval notation. This is where your numbers are included. So it says and equal. Where the previous example, the open interval notation, it doesn't include the number 3. It starts at like 3.05, something like that. But this one can start at 3. So if I had 3 is less than or equal to x, which is less than or equal to 7, on our graph, that would include 3 and 7. So we're going to have it filled in. And then we say that's closed interval. So it's between 3 and 7, so you're going to put this bracket around it. So let's practice this. Fill in the table. All right, so this first one, in interval notation, says that it should be greater than 3, but less than or equal to 8. So if I put x in the middle here, I'm going to say x needs to be greater than 3. Remember, from your variable, you want to read from your variable. Yes, x greater than 3 and x less than or equal to 8. That's saying that it's between those two numbers. So if I came up with the graph, we'd have our 3 and 8. 3 would be open, 8 would be filled in. Okay, if I just had one number here, x is greater than negative 2/3. It's easy to come up with a graph for that one. So here's 0, negative 1/3. So we're going to have a closed circle, since it's or equal to, at negative 2/3. And remember, read it from the x. This is saying x is greater than or equal to negative 2/3. So all the numbers negative 2/3 or bigger. Okay, for the interval, we haven't talked about this one yet. We want everything that's bigger than negative 2/3. So we're just going to start at negative 2/3. And then since it's or equal to, we'll put the bracket there instead of the parentheses. And it's going to go on forever. Look at your arrow. It's going to go on forever. So when does it stop? Stops at infinity. Okay? So when you write infinity or negative infinity, you'll always have a parenthesis there. All right, go ahead and pause the video. Try C and D. All right, so go ahead and check the last two, and then we'll go to one last example. Okay, graph the set. So number 3 is -4 to 2 or -6 to 1. Okay, so we want to include -4 to 2. So I'm just going to graph both these out. So -4 would be an open circle to 2. Okay, the second one, -6 to 1. And we want to know, this is the, both cases are true, the or. So it's kind of like the one where you're joining the two families together. So if we did that, then the ultimate answer would go from -6 all the way to 2. Okay, so then your answer would be -6 to 2 in interval notation. Okay, but the and, both cases have to be true. So we want only the overlapping part. So from -7 to 2, -2. There's the first one. Second one went from -5 to infinity. So where do these two overlap? So the only portion that they overlap at would be this little portion right here. Okay, so my new graph will just be between -5 and -2. So if I wanted to write this in interval notation, my answer would be from -5 bracket to -2 bracket. Okay, so direction said to graph the set. We would want to choose the graph that's in our final answer. So those are kind of like the graphs that help us get to our final answer, but you might want to just erase it and include only the one that you want. Okay, so again, the final graph for number 3 would just be the fact that it goes from -6 to 2, not including -6 or 2. And then for 4, that it goes from -5 to -2, including those. So we're going to put the brackets around them. All right, so your assignment, page 11 and 12, 41 through 65 odd, 83 and 84. And then you can look on Canvas. I have all the problems posted. Let me know if you guys need any help. I'll have office hours today. See you later.